Once we've got the basics of chapter 9.5 down, it's time to do some more difficult problems. For example, here is one. Convert the point from polar form, so we're given r theta, and we're asked to put it into xy form. The first thing I do anytime I'm given a problem like this is I want to draw it. So if this is our coordinate plane, I know as I go around with the angles, I have 0 and pi. Remember, pi is 3.14, which means half of pi is going to be 1.57. If I double 3.14, 2 pi is 6.28. And halfway between 3.14 and 6.28, I have 4.71. So if I'm going to graph this r theta, 4.5 with an angle of 1.3 radians, it doesn't say degrees, so I have to know that must be radians. So I am going to be somewhere between 0 and 1.57. Let's call it right there. So here is our point, positive 4.5, comma 1.3. So if I reflect that over the pole, here is my point, negative 4.5, comma 1.3. Notice that's going to be in quadrant 3. Just so we don't get confused, I'm going to erase this. But that was very useful to help me place this point. Now, what this question is asking for is, what is the x and what is the y? So we want to know, what is this x and what is this y? So we know that x is r cosine of theta, and we're expecting a negative. So make sure your calculator is in radians and do negative 4.5 cosine 1.3. Provided the angle is in radians, you'll get x is negative 1.20, which is what we were expecting, because we see that x from our pole, we're going, well, if it's the rectangular, we're going x is negative 1.20 from the origin, and y is r sine theta, so y is negative 4.5 sine 1.3, so y would be negative 4.34 when we put that in our calculator, negative 4.34 over here. So our xy point that accompanies negative 4.5, 1.3 for r theta is negative 1.20, comma, negative 4.34. And there is our final answer. And that was a little bit more tricky. We had to use our calculator for that because we don't know offhand what the cosine or sine of 1.3 is. We're asked to convert this rectangular equation into polar form. Remember, so important are our four bridges. X equals r cosine of theta, y equals r sine of theta, x squared plus y squared equals r squared, and y over x equals tangent of theta. Notice the right-hand side involved r and theta. Those are the polar side of the equation. The left-hand side involves x and y. Those are the rectangular side of the equation. So x times y equals 4. If I'm going to polar form, I'll make my substitutions. R cosine theta times r sine theta equals 4. Now this is this times this, so I can say this is r squared cosine theta times sine theta equals 4. And now I can say r squared is equal to 4 over cosine theta sine theta. In this, I'm given special instructions. I'm almost always trying to get r all alone to make r a function of theta. So we can leave this as r squared. And I would specify that for you. So r squared equals 4 times 1 over cosine theta times 1 over sine theta. And when we simplify further, we get 4 secant theta cosecant theta. And there would be our answer. Now, this is not r, but we can see that r squared is a function of theta. Here again, we're asked to convert this into polar form, and we've been given a rectangular equation. So we've got our 4 important bridges that allow us to transfer or jump over the water between rectangular form and polar form. So let's make our substitution. We know that x is r cosine theta to the 4th power, and y is r sine theta to the 5th power. Now this is r times r times r times r times cosine times cosine times cosine times cosine. So this is r to the 4th cosine to the 4th theta. And here this is r times r times r times r times r, and this is sine times sine times sine times sine times sine, which is r to the 5th sine to the 5th theta. Now we want to get r all alone. Just remember, let's go back on memory lane here. We said cosine theta equals cosine theta sine theta. And we said don't divide both sides by cosine and cancel to get sine theta equals 1. When you do this, you lose solutions. We don't want to do that. But notice that r is the directed distance. It's a constant. If I divide by r to the 4th and r to the 4th, these will cancel, and the 5th will cancel, and I'll be left with cosine to the 4th theta equals r sine to the 5th theta. So I can do this. Don't do that. We did that in the fall. Please don't do that. But you can do this. Note, you want to get r all alone, and we'll get r is equal to cosine to the 4th theta over sine to the 5th theta. Now, of course, I could write this as cosine theta times cosine theta times cosine theta times cosine theta, and sine to the 5th would be sine theta, sine theta, sine theta, sine theta, and one more sine theta. Well, I'll stick a 1 out here and make all of these fractions, and hopefully you can see that this is cotangent 4 times, so that's cotangent to the 4th theta, and 1 over sine is cosecant theta. What a great unit to remember our trig functions and some of our basic identities. So this would be our final answer. Notice I got what I wanted, r as a function of theta. So I could put r there, or I could put, as your calculator will show you, r is a function of theta. Either way is fine. Finally, we look at the problem, the one that is the reason we took pre-calculus honors. What a great problem this is. We see our 4 bridges and our messages to ourselves is convert this to polar form. Well, we can make some substitutions right off the bat, like r sine theta, the whole thing squared, minus 8 r cosine theta minus 16 equals 0. Well, this is r sine theta times r sine theta, which I'll make r squared sine squared theta minus 8 r cosine theta minus 16 equals 0. Notice now I've got sines and cosines. Why don't we hearken back to what we did last fall when we had a mixed bag of sine and cosine, and perhaps when I see a trinomial, I'm thinking, maybe I'd like to factor this. What we did in the fall is we said, we know that sine squared theta plus cosine squared theta equals 1. So if I want to write this all in terms of cosine theta, I can make a substitution. Sine squared theta is 1 minus cosine squared theta. So r squared times, instead of sine squared theta, I'm going to write 1 minus cosine squared theta minus 8 r cosine theta minus 16 equals 0. Distribute, distribute, r squared minus r squared cosine squared theta minus 8 r cosine theta minus 16 equals 0. Now, at this point, we have a lot of different ideas about good things to do and bad things to do. I noticed that I can factor this if I put it over to the other side of the equation. So I'm going to leave this little r squared there, and I'm going to add r squared cosine squared theta, and add 8 r cosine theta, and add 16 to both sides to give me this plus 8r cosine theta plus 16. Now, I did that because I saw I could factor it. What times what is r squared cosine squared theta? That's r cosine theta. And now I'm asking myself factors of 16 that will add up to 8. That's 4 and 4. And this will be r cosine theta. If I do plus and plus, let's see, this times that is that. 4 times 4 is 16. Here's where my money's made. 4r cosine theta plus 4r cosine theta is 8r cosine theta, which allows me to write it like this, r cosine theta plus 4. Because it's a repeat factor, we can say that's squared. And I want to get r all alone. So what I'll do is I'll square root both sides. And if I square root both sides, I'm going to get r is equal to plus or, well, if I square root both sides, I'm going to have plus or minus this. So that's going to be plus or minus this thing, squared square root. Think of the square and the square root undoing each other, and we're going to be left with plus or minus r cosine theta plus 4. That allows us to think about two different roads. The high road is plus and the low road is minus. So the first one is r is equal to, if I keep this as plus, I'll have r cosine theta plus 4. Remember, I want r as a function of theta. I can't define r as a function of r. So what I'm going to do is I'm going to get my r's all together. So if I bring this back to this side, I'll have r minus r cosine theta equals 4. And I'll factor out the r. R times 1 minus cosine theta equals 4. So divide by everything that's not r. R is equal to 4 over 1 minus cosine of theta. There is one answer. But we also had the low road as well. The low road was r equals the opposite of this, the opposite of r cosine theta plus 4. Well, if you understand, bring everything with r to one side, factor out the r's, and then divide, then you'll do it here too. This will be r equals distribute, distribute. R equals negative r cosine theta minus 4. So now I'm going to add r cosine theta both sides. R plus r cosine theta equals negative 4. Factor out the r, and I'll have r times 1 plus cosine of theta equals negative 4. And lastly, I'll divide by everything that's not r and get r is equal to negative 4 over 1 plus cosine of theta. What a magnificent problem. I've got these two different answers. R equals this and R equals that. I love this problem.